Okay, Chapter 18, Foam Firefighting, Liquid Fires and Gas Fires. We'll start out with describing the methods used to generate firefighting foam, and we'll talk about the materials and the equipment that we need to make or generate that foam. When using foam to fight fire, we're using several different methods that the foam is actually capable of doing, and one is separation, and it creates a barrier basically between the fuel gases and the ignition sources, such as our hydrocarbons in our type B or class B foams. It also has a cooling effect, which lowers the temperature of fuel and the adjacent surfaces. And as foam breaks down, it releases water that was used to make the foam as well, and will help continue to cool. Smothering, it actually is the prevention of air from reaching the fuel, and mixing with vapors and prevents the release of flammable vapor, and penetrating, which lowers the surface tension of water and allows it to penetrate fires into Class A materials. These are known as wetting agents. So with our Class B fuels, the foam, it separates, it smothers, it does have a cooling effect as it suppresses. With our Class A foams, we're interested in that penetration, the use of it as a wetting agent, and then it will penetrate into the wood or type A materials faster. So we have two types of foams primarily that we're using, Class B and Class A foams, which are used in two totally different applications. You got to remember that foam is just not foam. Uh, Class A foams are suited for specific purpose as well as Class B. Our Class A foams are intended for use on ordinary combustibles, solid fuels. It will help form a foam blanket and cool the fuel and also stop the burning process. In effect, that it does lower the surface tension of water and then allows that water to penetrate deeper to extinguish the fire. And this is the wetting, making water wetter, if you will. And then the water is released as the foam collapses down and deteriorates, and again will release water at that point and cause a cooling effect. Class B foams are intended for use on flammable liquids. Basically, it will form a blanket of foam and prevent or reduce the release of flammable vapor, especially effective on hydrocarbon fuels and polar solvents. In order to generate foam, we have to have a few things. We need water, which we're going to get from a water source and through our hose line. We need concentrate of the foam material in a concentrate and liquid form. For most cases, it's in liquid form. And then we need a proportioner. We use inline eductors, as we have in this example, to draw the concentration out of the bucket. It will mix it with air, or mix it with water rather, to make the solution coming out. And as we'll see in the next slide, we use our nozzle to aerate or add air to the mixture, and we'll then produce foam. So here we have the solution that we've generated running through our hose line, and the nozzle, whether it be in a special adapted nozzle tip or simply a fog nozzle, a combination nozzle that we're using fog on, will aerate and introduce air into the solution, and then this will produce our finished foam. With foam expansion, the degree of expansion will depend upon the type of concentrate that we have and the accurate proportioning or the mixture of the foam concentrate in the solution. The quality of the foam concentrate, shelf life and storage conditions and those kind of things will also make a difference, and the method of aeration and the sizing of the bubbles. So here we see some examples of our foam expansion. With low expansion type foam, a 20-to-1 ratio is used, and this is effective for controlling and extinguishing most Class B fires, also effective for cooling and penetrating Class A fires. Medium expansion, that 20-to-1 up to 200-to-1, is used to suppress vapor from hazardous material spills when applied at expansion ratios 30-to-1 or 55-to-1. Your higher expansion ratios are 200 to 1000 to 1. Typically, it's just used in confined spaces such as shipboard compartments, basements, mines, and enclosed aircraft hangar. A caution here, failing to match the foam type and the concentrate to the burning fuels will result in an unsuccessful attempt at extinguishment, and it could endanger firefighters. Likewise, mixing different types of foam can result in a substandard quality foam and can foul pumps and other equipment. So what type of nozzles are used? We may use a fog combination nozzle that we carry and have available on most fire engines. An air aspirating type nozzle would be a nozzle or a fog nozzle that has a aeration adapter that mounts on it, and a medium expansion nozzle may also be one that we use. Class A foams are designed to use on Class A type fuels. They're used in wildland and structural firefighting. Surfactants in the solution reduce surface tension of water in the foam solution, which allows better water penetration in the fuel and increasing its effectiveness. And it coats and insulates fuels, preventing pyrolysis and reignition. With Class B foams, they prevent ignition, extinguishes, and suppresses vapors from fires involving flammable and combustible liquids, such as polar solvents and hydrocarbon fuels. The rate of application will depend upon the type of foam concentrate used, whether the fuel is on fire or not, the type of fuel, and whether the fuel is spilled or is contained in a vessel, and whether foam is applied using a fixed system or portable equipment. Again, if the fuel is in a tank or a vessel, the type of tank will have a bearing on its application rate. With Class B foams, one of our goals is to produce a foam blanket that suppresses vapors from the unignited spills rather. So basically we're keeping this fuel from making vapors and vapors escaping. Foam concentrate supply should be at the point of proportioning before application begins. Once this application starts, it should continue uninterrupted until extinguishment is complete. Stopping and then restarting may allow the fire to consume some of the foam blanket that we've already applied. Rates of application. Polar solvents have differing affinities for water. The rates vary with the type and the manufacturer of the concentrate. Information sources such as UL or the Underwriters Laboratories, NFPA 11, and probably more importantly, the manufacturer's recommendations on the application rates. Hazards of foams, these concentrates can be mild irritants to the skin and the eyes, may be harmful if inhaled or ingested, can possibly degrade PPE, and most are mildly corrosive. And so with that, we can have, some environmental concerns. So to make foam, we need water, and then we need the foam concentrate, and we're going to make a solution. We're going to take that solution, and then we're going to proportion it with air to make a certain percentage of foam. So we'll take, if 3 gallons of foam concentrate plus 97 gallons of water equals 100 gallons of 3% foam. At a 6% mixture, 6 gallons of a foam concentrate plus 94 gallons of water would equal 100 gallons of a 6% solution of foam. Selection of the proportioner depends on the foam solution flow requirement, the available or correct water pressure, intended use for the foam, and the foam agent itself. Using a proportioner that is not compatible with the delivery device can result in an unsatisfactory foam or no foam at all. So most are using eduction, proportioning type systems. These are, it's a inline type device that we put in line with our fire hose, and they're required to operate at a certain PSI at the device itself. A lot of that is, most of them are 200 PSI at the eductor itself. And so you have to figure out your pump discharge pressure, friction loss on how much hose you have down before you get to the eductor and those kind of things. An injection type system, water moves through the pump. The foam solution, the onboard tank of the apparatus has a solution pump that will inject a certain amount depending on what we've set to make the correct solution on what percentage of foam that we have desired. Foam proportioning and pre-mixing, limited to one-time type application. The tank must be emptied and refilled before it can be used again. Most Class A foam solutions are biodegradable, and mixing and storing the solution for long periods of time can result in decreased foam ability. So a lot of pre-mixed tanks on these solutions or these wetting agents, we will dump the solution in the tank ahead of time, and this could be right before we apply it. If you're carrying onboard foam proportioners that inject, which a lot of people are carrying for type A or Class A foams now, that solution is stored in that tank, but again, it is biodegradable. After so much time, that foam is not going to make or generate the percentage of foam that we might be looking for. So we have to keep that rotated. In tank mixing or batch mixing of foam, we have to clean the tank out after we're finished using it. The proportioners are the equipment needed to produce a foam stream. We need a pump, fire hose, our proportioner, and then the delivery device such as the nozzle or some type of generating system. Inline eductors this is the devices that the type A pumpers are required to carry, and we will carry buckets of foam, 5-gallon buckets of foam concentrate. And with these, we need to follow the manufacturer's instruction about inlet pressures and your max hose lay between eductors and the nozzle, because it does make a difference on what type of foam or getting the right percentage of foam that it will generate. A lot of these devices have to be operated at 200 psi at the eductor, and then you can only have 50 to 100 feet of hose depending on the manufacturer after the eductor. The pickup tube is connected to the eductor at a low point, and the pickup tube is what draws the foam concentrate into the water stream. The eductor is built into the foam nozzle. Eductors are built into the nozzle rather than the hose line. The foam concentrate must be available at the nozzle. Relocating foam containers can be a problem with this type of nozzle. Supplies may have to be left behind if firefighters are required to retreat. So it's something to think about with the different type of systems that we have as to what type you're going to buy and what type you may use. Apparatus mounted proportioners. We have the inline eductor, the around the pump proportioners, and a balanced pressure. A lot are doing either the around the pump or the balanced pressure proportioners. Also, there's compressed air foam systems. They may be mounted on many different types of apparatus. The centrifugal pump supplies the water. Direct injection proportioning system mixes foam solution with the water on the discharge side of the pump. And then onboard compressor adds the air before it is then discharged. So you have compressed air or a compressor. We have fog nozzles versus foam nozzles. Two different types of nozzles that can be used. We have to realize that fog nozzles is something that we keep. Combination nozzles, we keep them. Almost every fire department has a fog nozzle. And so if they're able to spin enough and aerate enough, then they should make good foam. And then you do have a specialized foam nozzle as well. With fog nozzles, they produce low expansion, short lasting foam. They break the foam solution into tiny droplets. That's what a fog combination nozzle does, is breaks the water into tiny fine droplets. Use agitation of water droplets moving through the air to achieve the action of the foam. And then some nozzle manufacturers have foam aeration attachments to increase the aeration and make a higher expansion foam. So the advantages to this, like we said, that they're widely available. They may allow for variable flow and pattern of the application. The adjustable gallonage of the water as well. Faster application when we're using pre-connected hose lines. And they may allow a margin of safety if the foam supply is lost. Greater reach than foam nozzles. Foam nozzles are most effective appliance for generating low, medium, or high expansion foam. It inducts the air using a Venturi type effect. They're designed to provide aeration required to make the highest quality of foam, and therefore will provide the best expansion. Less stream reach than a fog nozzle. So some advantages of your foam nozzles. Typically produces a high quality foam that as opposed to fog nozzles, and they're useful in blanketing type operations. Disadvantages, they're not as versatile as your fog nozzle, and you have limited reach compared to other nozzles. Putting together a system, common reasons for failure to generate foam or for generating a poor quality foam could be the eductor and nozzle flow ratings do not match, preventing the foam concentrate from inducting into the stream. Air leaks at the proportioner device also can produce little or no foam. Improper cleaning of proportioning equipment. Nozzle is not fully open. We got to remember nozzles operate all the way open. Hose lay on the discharge side is too long. Our hose may be kinked, not giving us the flow. Nozzle is too far away from the eductor. Again, we have to follow the manufacturer's recommendations on hose length. Mixing different types of concentrates in the same tank, or an improper pump pressure. Next, we're going to talk about methods of application. Application techniques. We direct foam stream on the ground near the front edge of the spill. Foam rolls across the fuel surface, and we continue to apply foam until it spreads all the way across the entire surface and the fire is extinguished. When we're rolling on or using the roll-on method, we may need to move the stream to different positions to cover the entire pool. And this is used only on pool of liquid fuel that's on the open ground. So we're going to roll it on. The bank down method may be used when elevated objects is near or within the area of the liquid, the pool. Foam is directed onto the object and it runs down onto the surface of the fuel, and may be necessary to direct the stream around various points to achieve our total coverage and extinguishment. And this is used primarily on fires in diked up pools and storage vessels, and for fires involving spills around damaged or overturned transport vehicles. Rain down method may be used when the other two methods are not likely or feasible. Primary manual method used on above ground storage tank fires, and this directs the stream above the fire or the spill and allows foam to float onto the fuel surface and creating a blanket. The stream can be swept back and forth until the surface of the fuel is entirely covered and fire is then extinguished. It may be more effective to direct the stream at one location and allow foam to collect and then float out from that point on. Moving to a safe location, we want to remain alert to changing conditions, keep our situational awareness about us at all times. If the fire begins to spread uncontrollably, then retreat to a safe location. Use foam hand lines to protect the evacuation route. Water hand lines can be used for protection, but water may displace foam that's already been applied during the attack. Safe locations should be uphill and upwind. Vehicles should not be driven through unignited or burning fuels. They can reignite if they're hot enough and we disturb that vapor, what we're covering and suppressing the vapor. Next, operations that involve liquid and gas fuels. Flammable liquids, flash point of less than 100 degrees Fahrenheit and can be ignited without being preheated. A combustible fuel, your flash points are higher than 100 degrees Fahrenheit and must be heated above their flash point before that they can be ignited. So an example of a flammable liquid would be gasoline, and an example of a combustible liquid would be diesel fuel. So we have polar solvents and hydrocarbons. Hydrocarbons do not mix with water, they're not miscible, and polar solvents will mix with water. Our foam most often used to control the flammable liquid fires. Water is used as the cooling agent, a mechanical tool to move our blanket around, and the protection of the crew. Wind can spread flammable vapors. Again, we want to be upwind, uphill. So we want to determine the direction of the wind, locate our apparatus again upwind and uphill, establish our perimeter, report the conditions to all responding units, and evacuate any civilians in the affected area. We may request hazmat companies and remain outside of the hot zone, establish a water supply, and deploy attack lines as required. Avoid standing in pools of fuel or contaminated runoff. We got to remember that protective clothing can absorb fuel, which could lead to skin irritation and your clothing actually catching on fire. The pool could ignite. Benzene in petroleum product and the fumes is a known carcinogen as well. Remove soaked PPE from service until it is cleaned. Again, a warning here, PPE that is soiled with flammable and combustible liquids may ignite when exposed to heat. Next, we're going to talk about pressurized vessels. And particularly, we're dealing with propane, LPG, or liquid petroleum gas. This is stored in pressurized tanks or cylinders and transported by rail car and tanker trucks and even smaller trucks such as bobtail delivery trucks. It is an odorless gas that is heavier than air. Ethyl mercaptan is then added to give it that distinct smell that we smell. It is flammable, can be explosive under the right conditions. Response to a leak should include notification of the propane company, and we got to remember that heated tanks or cylinders can explode and send shrapnel great distances. Industrial pressure vessels commonly hold many different products in the industrial operations. Utility boiler units produce steam and heat. They operate above 15 pounds per square inch. Do not attempt to isolate operations of the pressure vessel without training. Obtain assistance from facility maintenance. We may control using the control valve, know exactly what the valve or the shutoff that is being closed and what system that it will affect. And this must be coordinated with the facility personnel or supervision. So we have to kind of know how to operate these valves. Gas main valves, this is showing us open and closed on our gas main. When it is in line with the pipe, it is open, and when it is crossing the pipe, it is closed. It's blocking it off. And then our butterfly operation, again, when the handle is in line with the pipe, it is open, and when it is crossing the pipe, it is closed. Boiling liquid expanding vapor explosions is something that we need to talk about when it comes to our pressure vessels. The pressure vessel that contains liquid or liquefied gas gets heated, and then the liquid will expand. It'll boil more and it will expand. This liquid will reach a boiling point and returns to a gaseous state. The vessel's internal pressure increases. The vessel begins to lose structural integrity, and at some point it is overcome and will rupture. The pressure and the contents of the vessel are then released. So liquid or liquefied gas must be above its boiling point at standard temperature and pressure. This is what produces an explosion. The tank failure may occur because of mechanical damage or direct flame impingement or contact. Many types of container breaches can happen. The PRD allows this gas to exit the cylinder. Your regulation, it's like a pop-off, and it will allow that pressure to vent off. Safety measures when we're fighting fires involving pressurized liquid fuel tanks. Fight fire from the maximum distance possible and apply water to the upper portions of the tank, preferably from an unintended master stream device. We want to flood the outside of the container with large quantities of water until after the fire is out. Direct water away from leak sources or safety devices. We want to leave the area immediately if you hear any rising sound, hissing sound from venting safety devices, or you see discoloration of the cylinder or the tank. Sections of the tank can fly in any direction So just avoiding the ends of the tank is not enough. Bulk transport fires, the extinguishment techniques are similar to those fires in flammable fuel storage facilities. We want to know the amount of fuel available, the possibility of the failure of the vessel, and any dangers to exposures. Always follow your pre-incident plans on these. Some additional challenges at fires that involve transport vehicles, flaming fuels, and fires that are involving flammable storage facilities. The increased life safety risk to firefighters from traffic. Probably one of the most dangerous things we do is operate on the highways. Increased life safety risk to passing motorists as well. A reduced water supply when we're out on the roadways, especially interstate highways. We're not going to have a fire hydrant right next to us. Difficulty identifying products that are involved, and we could have difficulty containing spills and runoff. Force of collisions weakening or damaging the holding tanks or cylinders and their piping. Also, instability of the vehicle can be a challenge to us. Additional concerns for civilians and civilian structures around because of the relocation of the incident. Traffic. Many incidents handled while traffic passes at normal speeds. At least one lane of traffic and the incident lane should be closed during the initial operations. Avoid using road flares. Kind of common sense thing there. Trained firefighters should be assigned to direct traffic and control access if law enforcement personnel are unavailable. Follow our proper highway procedures. Some additional concerns: tires could fail, which causes the flammable load to shift. The status and limitations of the water supply vary more than at fixed facilities, and it may be necessary to protect trapped victims with hose streams until they can be reduced. How do we determine the nature of the cargo? Bill of lading and manifest placards. We can ask the driver if they're around and able to offer that information. If these cannot be found, contact the shippers or the manufacturers. The environmental protection side of it is we want to prevent runoff of contaminated water and spilled liquids by blocking storm drains. And we want to block streams and runoff in ditches. Gas cylinder fires, fog stream patterns can be used as a crew protection when advancing to shut off valves. When pressure vessels containing gases are exposed to flame impingement, apply solid streams from their maximum reach until relief valves close. No angle or direction of approach is safer than any other angle. With the distribution systems, there's a vast network of surface and subsurface piping. The pressures can range from 1,000 psi in the network to 0.25 or a quarter of a psi. The excavation equipment breaking through pipes is generally the cause of most of these incidents. We want to call the utility company immediately. Apparatus should approach from and stage upwind side. We should wear full PPE and be prepared for explosion or fire. So typically these incidents come in where somebody has dug into a gas line, and even if they call for the utility spotters and they're properly marked, this is something that can still happen. They could be off on their markings or not marked at all when they should have been. This has happened many times in my experience, and you do have people that don't call and dig into something. We want to evacuate the area immediately around the break and downwind and eliminate all ignition sources. So running vehicles, smoking, anything that would be an ignition source. Check surrounding buildings for any odors of gas. Follow department SOPs that regarding crimping of gas lines to stop a leak. Most of these gas companies do not want you crimping lines. And the reason why is it can cause static electricity, especially in cold climates. And this can end up being a bad situation for whoever's crimping the line and can cause a fire. Use hose strings to protect exposures if necessary. Again, contact a utility company and an attempt to shut off pressurized gas supplies should be made. If there are street valves that we may be able to block off, that is something that we can do. We don't, once we shut a valve down or turn it off, we do not turn it back on. The utility company will handle that. Request hazardous materials teams if available and when necessary. The utility companies are prepared to respond to and to help take care of these leaks, and they'll shut the system down. Some of the valves in the system and these distribution systems will automatically shut down when a leak is detected. Again, if gas is burning from a broken gas pipe, do not extinguish the fire. Provide protection for the exposures. The utility company can block off and turn the gas off. To prevent reignition, occasionally reapply fresh foam to ensure that adequate coverage of the foam blanket is there. We don't want to walk through, drive into, or strike the foam blanket with solid streams or straight streams. Again, retreating to a safe location when the sound of gas escaping the relief valve may indicate the rupture is imminent. They can get pretty unruly when they're coming out of there, and they can make some pretty rude sounds. Foam hand lines may be used for protection. Water can be used, but remember, streams of water may displace foam that we've already applied. Safe locations should be uphill and upwind. Vehicles should not be driven through unignited or burning fuels.